You have your warm-up problem. It's on page 23 in your packet.
I could do this in my sleep with my eyes closed. Vince, are you the godfather? 1 + 1. Vince, the godfather.
How about page 23?
Yeah. I think one of the things I was missing was
Yes. I'm just checking that you have it. Yep. Good. You want to do this right now for the hormones? She heard.
That's fine. He is in class. I just gotta figure out what classes I'm missing. Oh, but I won't be here Friday.
Oh, I'm gonna miss so much.
I know. Just a heads up.
Thank you. Okay, you should be working on page 23 in your green packet. Yes, exactly.
Yeah.
Get in, get started. Page 23, those part A, B, and C. The formulas are in the box below.
Dude, that is so crazy.
So I will start today recording the lessons, so they'll be posted. I'm going to post them on my own YouTube channel. We talked about that before. They'll be on Blackboard, so under this rehearse link, I'll post the link to my YouTube page. It's going to look the same, pretty straightforward, just recording what we're doing in class every day. We're going to go through the 5-5 notes today. We're going to present problems from Friday. So I have Vince, Andy, Tyler, David, and Matt presenting. Vince, 58, Andy, 65, Tyler, 99, David, 105, and Matt, 123. For the problems we'll get to today. Your homework for tonight will be book work. We're going to switch back to the goal-free response. Pages 9, 11, and 13. There are no calculator problems we'll do on Wednesday. You're going to continue studying those formulas for the integrals and the derivatives of everything we've done so far from chapter 5. So can you integrate secant of x? Can you tell me what your 3 log rules are? And then by tomorrow you should have all your green free response done as well. So we're going to start grading that in class tomorrow. Take another minute here on the warm-up. Okay. Everyone have a good weekend? Yes. Glad to hear. Just peachy. Hopefully today isn't too bad here. So if you remember back from Algebra 2, the compounding interest formulas, there's two of them. We have A equals P times 1 plus R over N, all raised to the RT. So all of those formulas are down below what those letters mean. And then the compounding continuously formula, some of you might have heard it as A part, A equals P times E raised to the RT. So if we have an investment of $2,500, that's your principal rate or your starting value for P. And we have an interest rate of 5%. Remember, for interest, we write this as, we write that as a decimal value. Maybe. Let's see, why is this working fine last period? Okay, in investment, we're looking, this is off. After 5 years, that's your time value. So if it's compounded quarterly, the number of times it's being compounded in that year is 4. So your end value is 4. If it's compounded monthly, it's being compounded 12 times in a year. So your end value is 12 in part B. Hopefully that works a little bit better now. So using that formula now, let's try this. 10. A equals, there we go. It's going to be 2,500 times 1 plus your interest rate all over, we said n equals 4 here, raised to the n times t. So when you multiply all that out in your calculator, you get like $3,205.09. You're going to do the same thing for part B, but instead of 4 here, our monthly value, it's being compounded 12 times in the year. So you're going to get 2,500 times 1 plus 0.05 over 12. Raised to the 12 times 5. That value, you get $3,208.40. So you get about $3 extra if you compound over 12 months. Then continuously, we have to use our A part formula. Your principal is still $2,500. Your rate is still 5%, and you're compounding for 5 years. So here, this will actually produce the biggest investment, which will be $3,210.06. Everyone remember how to use this formula? It's pretty straightforward. Nothing really exciting there. So today we're going to talk about integrating and taking the derivative of values that have a base of other than e. So last week we took the derivative of e to the x. Derivative of e to the x is e to the x. The integral of e to the x is e to the x plus c. When we took the derivative of the natural log of x, we got 1 over x. When we integrated 1 over x dx, we got the natural log of the absolute value of x plus c. We said absolute value because when we find the value of a logarithm, our domain is positive values. So this should be a quick review from the log packet that you did a couple weeks ago. A to the 0 power, where a is just some constant, is 1. Anything to the 0 power is 1. A to the x times a to the y. Thanks, Vince. A to the x We have a to the x over a to the y. We subtract a to the x minus y. We have a to the x all raised to the y. A power to a power. Doug?
A to the x times y.
Yep. A to the x times y. Log base a of 1. That would be 0 because a to the 0 power would be 1. That's your inverse relationships. Log base a of x to the n. Using your log rules, remember that exponent can come out as a coefficient. So that's going to be n times log base a of x. Remember when we have log base a of xy, just some product, we can write that as log base a of x plus log base a of y. And when we're dividing x over y, we can rewrite that as subtraction. Log base a of x minus log base a of y. I will tell you right now, you should have these 3 memorized. Hint, hint, for one of your formula quizzes. You should have those memorized. Okay? So if you remember our inverse properties, if I have y equals a to the x, at IFF, if and only if, log base a of y equals x. That's what I just used to prove that statement as well. A to the log base a of x, that is just x. Log base a to the x, is also just x. That's saying a to the what power equals a to the x. Well, if my bases are the same, my exponents will also have to be the same. So far, so good. I'll review. So one quick review problem. If I solve for x, log base 2 of x equals negative 4. Using that inverse relationship, that's saying 2 to the negative 4 power equals x. Remember to make that a positive exponent. That is not the same thing as negative 16. That is 1 over 2 to the 4th power equals x. So x is 1 over 16. You did a ton of problems like that on your log packet. The last thing I want to point out, I talked to a couple of you on Friday about this, the change of base formula. It's not written down anywhere, but if you write it on the bottom of that page or the top of your next note sheet, definitely write this down. Log base a of x, that's the same thing as log of x over log of a, which is also equivalent to ln of x over ln of a. If you have a calculator and you're not convinced, I'll show you real quick here. So I'm going to use base 10 just because that's pretty easy to put in your calculator. So if I have log base 10 of 2, a little bit bigger than 3/10. So if I go ahead and use the formula log of 2 divided by log of 10, you also get that same value of 3/10. Then if you do ln of 2 over ln of 10, you also get that same value. So that formula does work, and we're going to use that to prove one of our derivative formulas. Okay. So write that down somewhere if you don't have it down already. So we're going to look at derivatives for bases other than e. So if I'm asked to find the derivative of y equals a to the x, the derivative is the natural log of a times a to the x. We're on the top of page 24 now. You can also say if I have a to the u power, same idea, but we have to multiply by the derivative of u. So why does that work? Well, if I'm looking at my original formula, y equals a to the x, and I take the natural log of both sides, so I have the natural log of y equals the natural log of a to the x. Using my derivative or my logarithm rules, I can say that's the same thing as x times the natural log of a. When I take the derivative of the natural log of y, I get 1 over y times y prime. The natural log of a is just some constant, it's just some value. So when I take the derivative of x times the natural log of a, I just get the natural log of a. It's just some value, a is just some constant number. Multiply both sides by y, so our derivative is equal to y times the natural log of a. Substitute back in a to the x. We have now derived our derivative, a to the x times the natural log of a. So if I'm asked to take the derivative of log base a of x, I get 1 over ln of a times x. And I'm going to pull this change of base formula to prove why that is true. So if I have log base a of x, that's the same thing as the ln of x all over the ln of a. So I take the derivative of the ln of x over the ln of a. Like I said, the natural log of a is just some constant. And the derivative of the natural log of x is 1 over x. So therefore, my derivative is 1 over the natural log of a times x. Be the same thing if it was log base a of u. We just have to multiply by the derivative of u as well. So far, so good. Not too bad. Couple examples. If I'm asked to find the derivative of 2 to the 3x, if you want to, you can label what your a value is. Your a value here is 2. My u in this case is 3x. And so the derivative would be 3. So just using the formula, the derivative equals a to the x, or a to the u in our case, which is 2 to the 3x, times ln of a, which is ln of 2, and then multiply by the derivative, which is 3. And that is our derivative. If you want to, you can clean it up. Just say 3 times the natural log of 2 times 2 to the 3x. A to the x times the natural log of a times the derivative of u. So here in part B, I have y equals log base 10 of cosine of x. I'm asked to take the derivative. While using the change of base formula, that's the same thing as the natural log of cosine of x all over the natural log of 10. We want to be a little bit more specific. It should say for x is greater than 0, just because cosine, the wave function, can get positive and negative values. So when I take the derivative, we don't have to use the quotient rule because the natural log of 10, again, is just some constant. If you want to pull it out front, you can. The derivative of the natural log of cosine of x, that's going to be 1 over cosine of x times derivative of cosine of x, which is negative sine of x. Last thing we can do is simplify. Well, if I have negative sine of x over cosine of x, it's negative tangent of x. So I can say my derivative is negative tangent of x all over the natural log of 10. Any questions? Formulas are pretty straightforward. We also talked last week the integral of e to the x was e to the x. Well, when we don't have base e, we have something of base a. If I integrate a to the x dx, I get 1 over the natural log of a times a to the x plus c. So why does this work? Well, one thing, I can rewrite a to the x as e to the natural log of a all to the x. That's using the inverse relationships. Like the e and the natural log would cancel out, so we'd just be left with a to the x. And I know a power to a power, I can multiply. So that's the same thing as e to the natural log of a times x. So using log rules and inverse relationships, a to the x is the same thing as e to the natural log of a times x. So my goal is to integrate. So if I integrate e to the natural log of a times x dx, I can use u sub. If u equals the natural log of a times x, du is going to be the natural log of a dx. ln of a is just a constant. So what I have to do is multiply inside by the natural log of a and outside by 1 over the natural log of a. So then I'll have the integral of e to the u du. When I integrate e to the u, that's just e to the u plus c, which is the same thing, e to the u, if I substitute back in, I get e to the natural log of a times x all over the natural log of a plus c. Going back, if I work backwards here, I said e to the natural log of ax is the same thing as e to the natural log of a to the x, which is a to the x. So after all of that, I get a to the x all over the natural log of a plus c. The hardest step is this, using this inverse relationship. It's not very intuitive. That is a proof of why the integral of a to the x is a to the x over the natural log of a plus c. Couple more examples here. So using that rule, if I'm to integrate 2 to the x dx, well, just using the definition, it's going to be a to the x, which is 2x, all over the natural log of a, which in this case is 2, plus c. All I did was take this rule and apply it. Last couple problems here. If I'm asked to take the derivative of e to the e, what would that be? Derivative of e to the e. It's
Would it just be 0 because it's a constant?
Yeah, I keep saying that. E is about 2.71. Raise the 2.71. You can put that in your calculator. You're just going to get some numerical value, which is 0. The derivative of e to the x, we talked about that last week, is just e to the x. One of those cool things in calculus. And part C, the derivative of x to the e power. I'm not. Ryan?
It'll just be ex to the e minus 1 power.
Good. This is just an application of the power rule. It was like x to the 4th, it would be 4x to the 3rd. Just bringing that e out front and then subtracting 1. No need to put e to the minus 1 into your calculator. Acceptable final answer right there. Last problem. Find y prime. I have y equals x to the x. What would be an easier way for me to work with this problem? Or what could I do to both sides? What could I apply to both sides to make taking the derivative a little bit easier? Did you say that? Take the natural log of both sides. Great. So if I take the natural log of both sides, I get the natural log of y equals the natural log of x to the x power. I can use my log rules. I get the natural log of y equals x times the natural log of x. We can take the derivative of both sides. The derivative of the natural log of y is 1 over y times y prime. To take the derivative of x times the natural log of x, I have to use the product rule. So I have x times 1 over x plus the natural log of x times 1. Clean that up a little bit. I get y prime over y is equal to 1 plus the natural log of x. Multiply both sides by y. And the last thing is to turn our y back into x to the x. Just substitute back in that value. So our derivative would be x to the x times 1 plus the natural log of x. How are we feeling? Okay?
Good.
Any questions? If there's no questions, I have the 5 gentlemen presenting from, supposed to present on Friday.
Is that from the 352 to 354?
Yes, 352 to 355.
Okay. I don't 100% remember what it asked me to do.
Same. Yeah.
We'll refresh. I think 58 is you're finding the tangent line.
58.
Yep.
Right in the middle there.
Let's turn the light on so we can get a little easier here.
Okay. So, oh yeah, I was asking for the, is it for the line?
Yes, the equation of the tangent line at the point 2, 1.
Okay.
Yep.
All right. So to find that, the first thing you would do is find the derivative of the tangent line at that point. So I just did y prime equals e to the u times u prime, which gives you that answer. And then you just find f prime of 2 because that's the x value that they give you. And after you solve that, you'll get 2e to the 0, which is the same as 2. So then your final line is y minus 1 equals 2 times the quantity of x minus 0. And I just cleaned it up and made it y equals 2x plus 1. I don't know if that's right. I hope it's right.
I think it was the ordered pair 2, 1, 2, 0.
Oh yeah. Oh, I'm sorry. Yeah, that would be
That's the only
2 times the quantity of x minus 2.
one.
I don't know why I put 0 there. Oh, that's because there was a 0 up there. Okay, never mind.
Other than
So that would be 2x minus 2. So that would be y equals 2x minus 1 instead of plus 1. Right? Because it would be
It's gonna be y minus 1 times 2 times x minus 2 in parentheses.
Yeah.
So when you distribute,
Yeah, you would end up getting 2x
minus 3.
minus 3. I just don't know how to do that.
This will become a 2 here.
And then do 2x minus 4.
It's gonna be
Yeah.
minus 4 plus 1.
Okay.
Minus 3. I'm not sure what Andy it was that didn't write it down. 65.
965.
Okay. We're finding the derivative, the tangent, and a tangent
Okay.
line at 0, 1.
Yeah, 0, 1 at x e to the y plus y e to the x equals 1. And the derivative of that, you do the product rule twice, and you get ey times x dy dx plus ey plus ex dy dx plus y ex equals 0. And then you solve that for dy dx by putting the dy dx terms on the same side, factoring out, and then dividing. And you get that, which is a lot of letters. And you substitute in 0 for x and 1 for y, and you get the slope to be negative e minus 1.
Got it. Yep.
And then you put that, and y, I just put in slope point form.
Yep. Point slope formula. So final equation y equals negative e minus 1 times x plus 1. The hardest part there was the 2 product rules, making sure that you have all your y primes aligned, but good job. Thank you. Tyler, 99. We're integrating now.
It asks for the indefinite integral, right? This one asks for the indefinite integral of that function. So I made the u the bottom part. So it'd be 1 plus e to the negative x. So the du would be negative e to the negative x. So that'd be the numerator. So I just threw the negative out in front of 1 over u. So it'd be ln of u plus c. Negative ln of u plus c. So I plug the u back in, and then that wasn't the final answer they gave you. They gave you this one as the final answer. So to get there, I made the e to the negative x 1 over e to the x, and then I found a common denominator. So it'd be e to the x plus 1, or e to the x plus 1 over e to the x. And then I used the log rules to make it ln e to the x minus ln e to the x plus 1 plus c. So then ln of e to the x is just x. So the final answer would be x minus ln of e to the x plus c, plus 1 plus c.
So the hardest part there is, yes, you saw was pretty easy, but then going forth and using those log rules. Is that our bell?
That's our 6 minute.
Thanks, Tyler. David, you got 105. Also integrating.
Alright. So 105 was like that's pretty simple. So you can take or you can do like monomial division, I guess, with e to the 2x, and you can split it up into 2 integrals. So it's the integral of 5 e to the negative 2x dx minus the integral of e to the negative x dx, and then you integrate those. And yeah, so that's it.
Didn't show all your work, but yes. Integral of e to the negative x, it's going to be minus negative, so plus. You can bring 5 out as a constant and e to the negative 2x. You can integrate using u sub. Yes, that is the correct answer. Didn't show all your work, but.
It's a minus 600 times.
And Matt. 123.
Alright, so they said, or they gave you the double derivative, which was 1/2 times e to the x plus e to the negative x. And they said f of 0 equals 1 and f prime of 0 equals 0. Or, yeah. So you have to integrate, and so you took the integral of 1/2, you took the derivative, or you took the integral of the double derivative, and you get 1/2 e to the x minus e to the negative x plus c. And then you use what they gave you, so it's 0 equals 1/2 times e to the 0 minus e to the 0 plus c, and you get c equal to 0. And then you have to take the derivative of that again to find f of x. And the integral of that is 1/2 times e to the x plus e to the negative x plus c2. And then you plug in 0 and 0, and you get 1/2 times e to the 0 plus e to the 0 plus c2, and that's you get c2 to also equal 0, and so your f of that, your function is 1/2 times e to the x plus e to the negative x.
Kind of interesting, because that's what you started with. So you take this second derivative of f of the x, you get the same as your original f of x.
They were trying to teach us a lesson.
What goes around comes back.
Yeah. No, that's a good lesson for you. You know what it is?
I have 4 problems for tomorrow. Any volunteers for presentations? 43 done.
Not a good number of
I need 3 other people present tomorrow.
I just wrecked you.
Any volunteers? I need 63, 65, and 77.
We don't have 23.
Nick, you want to do 63? Thanks. 2 more. 2 more. I'm going to pick people. What?
Do it. Okay. This is like your 15th problem. That is someone so many
Okay, 65 is going to be Erica. And 77 is going to be Matt. So are you doing the Matt, you just did a problem today. 77 will be Ryan M.
Oh.
For tomorrow, you should have the bookwork done. All your green for your response should be done. We're going to start checking those tomorrow. Oh, those presentations are for Tuesday's homework, huh? There were no presentations. No, they're Tuesday night homework. 43, 63. I don't write the problems being presented just because it's like double work. I think so. 43, 63, 65, and I didn't write 77.
What are you
It's gonna present from the.
Okay, yeah, I was confused. You confused me. I was like,
Yeah, please don't open this. Bookwork, read your response, study your derivative and integral formulas, and goal for your response is going to be due on Wednesday.
You guys, Wednesday, the 28th, pure media.